The question is asking us to graph r equals 4 cosine 3 theta and compute the area in one loop. To draw the graph, I like to first simply draw an x and y graph of 4 cosine theta because that's going to guide me through the whole problem basically. 4 in front of cosine theta means the y limit will change from -1 to 1 to 4 to -4. Draw a graph going up to 2 pi, and then I'll draw the new graph for 4 cosine 3 theta. So we repeat the graph that we drew 3 times, and then we label the endpoint 2 pi. So middle of that graph is pi, and from 0 to pi, the middle of the graph is pi over 2. And then we have to find out when the graph hits 0 first. For that, I'm going to set 4 cosine 3 theta equals to 0. And then I'm going to go to the original graph of 4 cosine theta and see when that hits 0. So that hits 0 at pi over 2. So I'm going to see when is 3 theta equals to pi over 2. That's theta equals pi over 6. So the point where graph hits 0 first is pi over 6. And then the minimum would be pi over 6 plus pi over 6. We're assuming that the graph is symmetrical. And we can see that it's symmetrical. It's a logical assumption to make. So now I'm going to draw an x and y plane because I like to draw this graph at x and y plane as well. And the dotted lines that I'm drawing, they and the x and y plane have a distance of pi over 6. So then I'm going to go ahead and label the angles and then start drawing the graph. At 0, the graph starts at 4. As it goes to pi over 6, it approaches 0. So that's how I drew the first line. So that's how I started sketching the graph. After that, you have to remember that if the value is going to negative, after pi over 6, the value starts going negative, right? From 0 to -1, 2, 3, and then when it approaches 4 at minimum. When it's like that, you have to go in the opposite direction. It's like if you're moving in left, you start moving to right. If adding 180 degrees or pi makes more sense to you, then that's fine too, because that's basically what you're doing. Just go in the opposite direction and on the opposite angle if the y value is going in negative. And yeah, after that, basically you just draw the whole graph the similar way, and when the graph starts repeating, that's when you stop drawing because there's no point in drawing the graph after that. And then you're finding the area of one loop. For this, what I like to do is I like to take the angle pi over 6 and negative pi over 6. You can try and find those fancy angles, which is completely pointless and unnecessary work. So pi over 6 and negative pi over 6 is the easiest way to do it. Remember, the area is equal to 1/2 r squared d theta. Theta. And after that, the identity that I use to solve that is cosine 2 theta equals 2 cosine squared theta minus 1. And since we have cosine squared 3 theta, the whole equation is going to change to cosine 6 theta equals 2 cosine squared theta minus 1. And you basically take the value that you got for cosine squared 3 theta and then you plug it in. So it's easier to find the integral. So you can take out all the constants and then you can find the integral, that is cosine 6 theta's integral is sine 6 theta over 1 over 6, and 1 becomes a theta, and then you have to plug in pi over 6 and negative pi over 6. Sine of pi is equal to 0, and sine of negative pi is equal to 0 as well. All that we're left with is 4 multiplied by pi over 6 plus pi over 6, which is equal to 4 pi.